Video collections in panoramic contexts. With geotagging, it is easy to assemble a video collection of a place which shows both the moment-to-moment comings and goings and the longer changes over days, months, and years. Interfaces to video collections often fail to make these spatio-temporal relationships apparent. Recent state-of-the-art interfaces attempt to solve this problem for outside-in datasets, but these approaches cannot handle inside-out datasets where there is no necessary overlap between neighboring videos. Instead, we embed video collections within panoramic contexts using sensor data from mobile phones and vision-based visual fitting for alignment. While watching a single video can be interesting, our interface allows us to see it in context. Here, we use only sensor data from mobile phones to compare videos from different seasons inside the panorama. Clicking on a video presents the local timeline. Users can scrub this timeline to explore individual videos temporally, and this temporal control has spatial extent in the context. Viewing videos within a common context makes it easy to observe the changes in static and dynamic content between videos. Videos can also be selected and filtered on a global timeline. Scrubbing the global timeline causes synchronous progression among all videos. Here, even though the videos do not visually overlap, we can still track a person from one video to the next within our context. Such relations are difficult to explore when the videos are seen out of context. With more than 20 videos, this dataset creates a moving collage effect within the context. Here, we see the user searching for interesting content by scrubbing the local timelines of videos. As this operation has spatial extent, it is easy to reject unwanted spatial or temporal instances. Our spatiotemporal index helps perform search and filtering operations. We visualize this here with a heat map, showing video attention across the context. Selecting an individual video shows its contribution to the index. Users can directly scrub the panorama to spatiotemporally move the video. Our system also allows the video to be filtered by spatial bounds. Here, the user drags the bounding box to describe a region, and our interface automatically fills the region by selecting intersecting videos. Finally, for this dataset, we show multiple videos being scrubbed together. The user right-click drags anywhere in the context, and videos automatically arrange themselves to be closest to the user's requested spatial position. The equirectangular 360-degree at once view can be switched at will to a perspective projection, which maintains straight lines. The video foci let us see changes in the environment, such as the poster boards in the hallway not present in the context. The view can be locked to a single video to allow easier comparisons with the context and with other videos. Contexts themselves can also change over time by scrubbing the global timeline. Our video collections plus context representation fits display and interaction devices beyond desktop environments. On tablet devices, rotations naturally respect the geometry of inside-out video collections to provide a virtual window effect. Further, using the front-facing camera and face tracking, we provide zoom controls to augment the physical act of pulling the tablet closer. Of course, these world mapping controls can be toggled once a region of interest is found to revert to a more standard touch interface. More exotic representation mappings are also possible. Here, the inside-out dataset is viewed outside-in on a spherical display, allowing multi-person viewing and collaboration. A joypad moves the cursor to select videos, and analog triggers provide time manipulation. Other controllers are possible. Here, we use a tablet as a proxy controller. The state of the context is mirrored on the spherical display. A multi-touch interface would also be technically possible, allowing manipulation for many people at exhibits. Finally, we show video collections viewed in situ, where the real world becomes the context. We imagine tourists guided by GPS to hotspots where they can compare videos of past events to the current environment.